Okay, this is 7.1 Notes, Part 2. Pre-calculus. Math Analysis Honors. Here's where we left off, Gauss-Jordan elimination. And we'll start off with an example like that. Rewrite the augmented matrix in row echelon form. Remember that row echelon form? Means we want to have ones on the diagonal and then zeros all underneath. So if I take a look at this particular matrix here, if I multiply the second row by a negative 1/2, then my next matrix will be -1, 1, 3, -3, 1, 0. Okay, and I can see that if I take the two rows, row 1 plus row 2, and I add those together, then that should give me, leave the first row the way it is, and I should get -1 plus 1 is 0, 3 minus 3 is 0, and then 1 plus 0 is 1. Now take a look at this here. This is actually where we can stop. And if you think about it, remember that this is a system of equations. The first column represents x, the second column represents y. And I can make an equation here that says -x plus 3y equals 1. But on the bottom, I'm going to have 0, because they're both zeros. 0 is equal to 1. And we know that's a false statement. That is not true. And therefore, we can conclude this system has no solution. Note that this system of equations has no solution. So when you get something that says 0 equals 1, or 0 is equal to 3, or 0 is equal to -10, that means that all of your variables have dropped out and there's going to be no solution. Take a look at example 5. Please notice that we've changed the example. Alright, so we have a system of equations. 2x plus 4z equals 8, 2x plus y plus z equals 10, x plus y minus z equals 6. The first thing I'm going to do is form an augmented matrix. 2, 0, 4. Notice that I'm putting a 0 there because there's no y coordinate, or there's no y component. Okay, so 2, 0, 4, 2, 1, 1, 1, 1, -1. Augmented with 8, 10, 6. Notice that I've got a 2 and a 2 here. So why don't I take row 1 minus row 2? That means my next matrix should be 2, 0, 4, 8, 0, -1, 3, -2, 1, 1, -1, 6. So the whole idea is I'm trying to make zeros along the bottom part of the matrix. Let's take 1/2 and multiply it by the first row. So now I have 1, 0, 2, 4. That turned out pretty nice. Okay, so my next matrix, I have a 1 on the top diagonal there, and I have a 0 underneath. So far, so good. What else can I do next? See this 1 and 1? Why don't we do row 1 minus row 3? It'll give me 1, 0, 2, 4, 0, negative 1, 3, negative 2. Those stay the same. In the last row, 0, negative 1, 3, negative 2. Looks like I've got some pairs here. So what if I subtract row 2 and row 3? Then my next matrix will be 1, 0, 2, 4, 0, negative 1, 3, negative 2, and then all zeros on the bottom. How can we interpret this? It's like saying that there is no equation, there is no third equation in the bottom. But the two equations I could make are x plus 2z equals 4 and negative y plus 3z equals negative 2. But z isn't constrained. There's no third unknown equation. So that means z can be whatever we want it to be. All right, since z is not constrained, the system has infinite solutions. All right, so when you're putting something in row echelon form and you end up getting an entire row of zeros, that means the system's going to have infinite solutions. So far, so good. Let's take a look at an application. At the school picnic, you sold 20 hamburgers, 30 hot dogs, and 60 waters, and managed to raise $240. We can write an equation out of that. 20 hamburgers plus 30 times the price of a hot dog plus 60 times the price of a water equals $240. A hamburger costs 3 times as much as a hot dog. A hamburger costs 3 times as much as a hot dog. A water costs half as much as a hot dog. A water is half the price of a hot dog. So how can we form an augmented matrix here? It looks like 3 equations. It looks like 3 unknowns. But we don't want a variable to be on the right side of the equal sign. So instead, why don't we subtract 3d from both sides and subtract 1/2 from both sides? And we'll write h minus 3d equals 0. W minus 1/2 d equals 0. Now I can form an augmented matrix. 20, 30, 60, 240. 1, that's the coefficient here. 0, negative 3, that's the D column. 0, 0. Now look at this one. This one has to go here. That's the water column. The hot dog column with negative 1/2, 0 there. And now you have an augmented matrix. Find the price of each item. So the first column are the hot dogs. The hamburgers. The second column are the dogs, D. The third column represents the waters. Try Gauss-Jordan elimination to find the price of each hot dog, each hamburger, and each water. Okay, hopefully you paused the video for a little bit and tried it. It's going to be a long amount of work, but here it is. Now I've gone ahead and done a lot of work and showed every single step. You can combine some of these steps together, but I've done all of the row operations, and if you look at the bottom where the answer is, I've managed to turn the matrix into reduced echelon form. So that means H is equal to 6, the dogs are equal to 2, and the waters are equal to 1. So $6, $2, and $1. And that is it. Have a nice day.